Okay, so thanks a lot to Akash. That was a great presentation on code standards and linting and being consistent and just writing good code. So the visual presentation is part of writing code for sure. Okay, so we're going to talk about something called test-driven development right now. So testing is a very, very important part of writing professional quality software. It's something that people often don't like doing and avoid doing, and so it's one of those things where people really dislike doing it and try to do as little of it as possible. But it's very important. So when you're just writing one little function, maybe it's not such a big deal. But once you start writing very, very complicated applications, it's important that you know that everything works, or at least is as close to that as possible, so that when things go into production and they're operating, you can be reasonably confident that you're not going to come across unexpected bugs. Okay, so there's a so let's talk about like poor man's tests first. So we actually have been doing testing, right? So there's an official methodology called test-driven development, which we'll talk about in a sec. But there's also just kind of ad hoc testing, which we have been doing all the time. Anytime you try to run a function and look at the output on the console, you're running a test, right? So let me share my screen. That is not the right one. Yes. Okay. All right. So here we go. We have a function here, and we want to run some tests on it. So what we do typically is something like, okay, so as I'm writing this function, I have this function called get first letter. It's going to take in a word, and then I'm going to return the first word, and there's some error checking, right? So if maybe I give it a number or something, there's no index available, it'll throw an error, and then I get -1. So let's just run it and see what happens. Print get first letter Bob, and we'll copy this. Maybe something like 3. If I run this, okay, I get B and -1. So it looks like this works, right? So that's fine. I've got I wrote a function, I wrote a couple tests. I test this edge case, looks like it works. I test like a standard case, it works. So that's pretty good, right? So that would be this is a kind of testing, but it's ad hoc. It's not really systematic. It's hard to apply to a much larger, more complicated code base, and it's also very individual dependent. So there's another, we can kind of step up our game just a little bit by using something so I guess I should mention at this point, there's something called, there are all kinds of different levels of tests. We'll talk about this more in a second, but there are unit tests, something called integration tests, or sometimes there's another component test category in there too. But basically unit tests, integration tests, and UI tests, or end-to-end tests. And we're going to be focusing on unit tests. And unit tests is basically testing an individual function. So at this point, that's essentially what a unit test means. So I write a function, I test it. I write 3 functions, I write tests for all 3 functions. So those are unit tests. Just one piece of functionality, I can test it. Integration test is I want to test the way that all of these different functions interact with each other. So if I have a larger piece of code and I'm importing a couple other files, integration test would make sure that everything plays nicely together. So you write unit tests for the individual functionality, and then you write integration tests for for the largest thing. So I'm just going to show real quick. Thought this was kind of funny. Stop sharing my screen and I'll share. All right, so here's an example of unit tests versus integration tests. So unit tests, just individual components, the smallest level possible, like functions basically. Integration tests is testing a larger system, how these individual components work together. So checking the lock, okay, that works. The lock works, the unit test passes, but integration test fails. Okay, so we have unit tests, which are very important. That's going to be the main focus of what we're talking about. Integration tests and UI tests, or end-to-end tests. Sometimes you'll see different terms. Okay, so let's go back to our example here. So the kind of test we want to write here is a unit test. We have a single file with a single function in it, and we just want to write some tests to make sure that this particular function is doing what it's supposed to do. So again, we could just throw this in here, but if this is a production code base, we can't just leave a bunch of print statements lying around the code, because anytime someone imports this file, these print statements are going to run, and it's going to clog everything up. It's kind of a mess. So there's a standard kind of device that's used in Python to avoid this issue, which is, it's something you'll see over and over again. I'll explain it in a sec, but if oops. So I'm not going to talk a lot about this, but this is basically checking, is this file being called directly, or is it being used, is it being imported into another file? So this kind of step up from poor man's testing, this is the way a lot of Python unit tests used to be written. You include the unit test for the module here, and if you import the module, this won't run. So if I use this model, or this function in another file, these aren't going to run. But if I want to run, unit tests, I can run this file directly. So let me add another file, main.py, and we'll import the file, get first letter, and then we'll do am I printing here or returning? I can't remember. Returning. Okay. So I'll do something like this. Oh, whoops. Print. Okay, so what I'm doing is I'm importing this file from here, and then I'm calling it here. So we use the dot notation. So this represents the file name, import get first letter, it's the name of the file. Then I'm calling the get first letter function, which belongs in this file. So that's how I use the import. So if I run main, okay, so it ran, and notice that none of this stuff ran. I didn't get any output, but I'm not gonna worry about that. So what happens if I run this file directly? Let's see what happens. So now these statements run, right? So when I run the file directly, I can run these, so I can put like my little ad hoc unit tests in here. So that's a step up from what we were doing before. And you're gonna see this all over the place. So name will refer to, if I call this directly, name will be main. If I call it as an import, name will be the name of the file. That's just how Python does it. Okay, so that's kind of we're going up the hierarchy slowly. We started with just kind of ad hoc as we're developing console log or print statements kind of stuff. Now we're stepping it up a little bit. We're treating this like a module. So we're distinguishing between running it directly when we're testing versus actually using it in production. But there's another level we should be shooting for. And before we get into using Python's unit test module, I just want to talk a little bit more about test-driven development as a philosophy. So test-driven development is basically the opposite. It's a methodology for coding that's kind of the opposite of what you would think and what most people would prefer to do. So you start with the tests and then you write your code after that. So typically we think of we'll write code and then we'll write tests to make sure our code's working. But test-driven development inverts that. So we write tests to determine what we want our code to do, and then we write code to pass the tests. So that's the basic approach. It's kind of inverted. So test first, code second. And that approach leads to this. There's a process that you follow in order to do that, which is called red-green refactor. So red-green refactor, so the red means failing tests. So the process is I have a requirement. So I need some kind of functionality. So I am going to write a test. And I'm going to write a test just to test the smallest part of that functionality that I want. And that test is going to fail because I haven't written any code yet, right? I'm starting with a test. I've only written the test. That test is going to fail. So once that test fails, then I say, okay, how can I write some code that will pass that test? The minimum required code to pass that specific unit test. So I write the code, and then once the test passes, I stop. So that's the cycle. I can also refactor, but we'll just skip that. And then I go back. Okay, so now it's red-green refactor. So I go back to green, or I go back to red. So red. Okay, so what else? What other feature do I need to get this solution that I want? Okay, so I add another feature. I write a test. Again, a small limited test that's just enough to get me to that next phase. And then I run the test and it fails. So it's red, right? So what do I do with a failing test? I try to write code to pass it. And I write that code just the minimum necessary to pass that test. So once the test passes, it's green, and I start back over again. So it's just this constant cycle of small iterations. So I start with a test. I have some functionality that I want. I write a test that describes that. I write code that passes the test, and then I just keep going over and over and over again. So these little baby steps. So that's the basic approach to testing. And here's an illustration. So thinking about the requirements, whether that's you thinking or you're getting requirements from someone else. Then red, green, refactor. So you also need to think about how everything else works. So refactoring is a part. We've kind of skipped over that, but red, green, refactor, red, green, refactor. That's the process. Okay, so now that we have some idea of how test-driven development works, this inverted, counterintuitive way of writing code, let's look at Python's unit test. So Python. So we've seen NPM modules, right? And we'll look at another one in a minute for testing JavaScript. But so Python has the core functionality of the language, things like I can call, I can append something to an array. There's all kinds of built-in functionality that I can use. There's also this second layer, which is called the standard library. So the standard, let me share my, okay. So the standard library is an additional layer of functionality that you get for free with Python, but you have to explicitly import it in order to use it. You don't need to download anything extra. You don't need to do anything, but you do have to import it. So there are a number of more specialized features of Python that are included in the standard library, Python standard library. that you'll need to import. So one of them is something called Unittest. So Python comes for free with this framework for doing unit tests, which is exactly what we're talking about right now, right? We want to write very specific low-level tests that will test individual functions. So here's the documentation, and documentation is often kind of bewildering, and there's so much going on here, and I don't understand it, and you have to be an expert in order to understand the documentation. So this is just part of the catch-22 of being a software developer, where you need to understand it before you can understand it. But that's how it is. So you got to keep pushing through regardless. But here's the documentation for unit test, and we can just kind of quickly look through. So unit test, it's a testing framework originally inspired by JUnit and so on. Okay. Test fixture, I don't know what that is. It looks complicated. Test case, okay, that looks like it might be something that I can use. Test case is the individual unit of testing, okay? It checks for a specific response to a particular set of inputs. Okay, so that looks similar to what we were doing before, right? Except we were just doing it visually. We run a function and we print out a result, and then we look at the console. So we're basically checking what does the function output versus what do I expect it to output. We're not formalizing that check, but that's what we're doing. Okay, so unit test provides a base class. Test case. We haven't talked about classes, so I'm already confused. We're going to go ahead and use it. We're not going to go into detail about classes just yet. We'll do that next week. But so frameworks have different APIs. This particular one uses classes, so you have to use a class, unfortunately, in order to use this library. Okay, so so I know in general what this unit test framework does. I can at least I know that I can access something called test cases, and I can compare what my function outputs with what I expect it to output, and that it uses classes. Okay, so I have a general idea of what's going on now based on the documentation. So, I get an example. That's always good. Documentation sometimes is very, very unhelpful. Sometimes it's very helpful. It just depends on who's writing it. Here we have an example. So that's nice. The module provides a rich set of tools for constructing and running tests. This section demonstrates that a small subset of tools suffice to meet the needs of most users. Well, that's good, because I don't want to learn a whole bunch of stuff. I just want to learn one or two things and get the job done. Okay, so here's a short script to test 3 string methods. So it looks like this, they give you an example of a working program. So what I'm going to do is I'm just going to copy this. This may be a bad idea, but I'm just going to copy this and I'm going to paste this in here as is. So it looks like that's okay. That worked all right. So I'm going to, well, I'll stop sharing my screen in a sec. So I'm going to take that and paste it. Right here below it says a test case is created by subclassing unittest.testCase. Okay, so I don't know anything about classes, but looks like that's what's happening here. The 3 individual tests are defined with methods whose names start with the letters test. Okay, so I have a bunch of methods here. Methods are functions that are inside of classes. So test, test, test. Okay, so I'm looking at the example and I'm noticing some patterns here, and the documentation is helping me out. So looks like all the stuff that I write is going to have to be called test underscore something. This naming convention informs the test runner about which methods represent tests. Okay, so that's fine. It looks like if I want to write tests, I just have to make sure to call my methods test underscore something. All right, so I'm gonna go back to my other window here. Okay, so I'm back to my code editor. I just copied and pasted the example that I got from the documentation in here. It looks like there's some things that maybe I don't maybe aren't going to be specific to my use case, just general. So one is importing unit tests. So we're going to have to import unit tests if we want to use it. It's part of the Python standard library, but we still have to import it. Here, again, we have this name versus name equals main thing. So we're familiar with that. It doesn't really matter. We'll just, that just tells us that we're probably going to want to run this file directly. And then this unit test.main, this is just a built-in thing. This is just part of how the API works for unit tests. So we're not going to worry about that. So it looks like this is going to run our tests. So what we do have to worry about, well, I guess we could change the name here. So before we go further into developing some tests, let's talk about what we actually want to test. So what we actually want to make. So we're going to make something through tests. So let's say you're working at your big company, whatever, you're working at wherever you're working, and your boss gives you something called a story. So a task, or an order, or whatever you want to call it, a story. That's nice. Sounds nicer, right? Story. So something you have to do, and the thing you have to do is you have to write two functions that allow a user to submit a URL, and this is all going to be kind of fake, but allow a user to submit a URL, and then you're going to return the relevant web page. So we're gonna talk about Django in particular in a little bit. So there's something called there's views and models that part of your application interacts with the database, part of your application handles routing, part of your application serves up HTML and so on. So we don't have to worry about that right now, but we want to write two functions that kind of loosely model this basic structure, where I'm going to go, I submit a URL, and then I get a web page in response that matches the URL that I submitted. So that's what we want to write. Okay. Now, in order to do that, so we can change the name of our test class. So we'll call it web app tester or something like that. And I'm just going to delete these other ones because I don't really care. And then something like test upper. So let's start thinking about what we want. So the first thing that a requirement, it needs to have this function called URL parser. So let's write a test that tests that the URL parser exists and returns some value. So there are a number of different methods. There's assert equal. There's a few others. Maybe I can go back to the page there. Let's see if there's a list of methods. Here we go. Here's some stuff we could use. So here's a bunch of assertion statements. So assert equal, assert not equal, assert is not, assert is not, assert is not none. Okay, so that might be what we want here. So we want to write a function and just the bare minimal functionality. We basically just want to check that it exists and that it will return something. So let's go ahead and we're going to change that. We're going to do assert is not none. Let me switch screens again. Okay, so we'll do assert is not none. See, and the autocomplete comes up here, so that's nice. And it looks like this takes just two things. So it's just going to compare two values. So we'll have to call our function and then compare it to a value. That's actually how most of them work. This particular one, I think, is just going to take one. So if we want to call our function, we can't just call it here because it's in another file. So we're going to have to import it again. So we're going to import web app. That's the name of our file. and we're going to change the name of this test to test. Let's see. Router exists and returns something like that. Okay, so router exists and returns. We can also add a doc string that will, so we can describe the test that we want, or the functionality this is supposed to actually implement. So we can do this tests that the router function returns a value. Okay. So we do self.assert is not none, and then we'll pass it web app dot, what's the name of the function that we want? We can do URL parser. That's what that was called. Okay, URL parser, and that's going to take in some kind of string. So let's try run. We're getting a little squiggly, but it's supposed to fail. So let's go ahead and run it anyway. So Python web app tests. Okay, so I ran this test and I get some output on the screen. Let me magnify this. Okay, so I ran a test and I get an error. So it failed. So I ran one test, tells me that it ran one test and that I have a failure, and that failure is an error. And right here is the doc string that I put in. So, you know, documenting what you're doing is nice. This particular API, the way that it's written, if you include a doc string here at the beginning of the function, it'll let you know. So when you're running a whole bunch of tests and one of them fails, it's nice to be able to look at this quickly and see what the test was supposed to be doing. You know, if you have 100 tests, you're not going to remember specifically what everyone is supposed to be doing. Okay, so that's good. So we're, you know, if we recall, the test-driven development cycle is red, green, refactor. So we're now at red. We've thought about our requirements. We have a minimum implementation. We write a test. The test fails. So now we have to write some code that's just enough to make this test pass. So we have a function called URL parser. Def URL parser, and that will take a URL, and that says return. Basically, just need to return anything. So let's just return URL for now. So as long as this doesn't return nothing, it should be fine. So we've written the functionality. Let's see if it passes the test. Okay, so it does. Let me clear. You can see that it ran one test, tells how long it took, and okay, that means all the tests pass. And we get a dot here. Whereas before we got an E. So if the test passes, you get a dot. And we'll write more tests and there'll be more dots. So you can get a D, you can get an F, you can get an E. For like a dot is passing, an F is failing, and an E is an error. An error is failing. Okay. So good. So we went from red to green, right? So now we need to go back and start the process over again. So red, green, refactor. Let's look at another requirement. So it needs to allow users to submit a URL. Okay, returns relevant URL. Okay, so we don't just want to return the whole URL. We just want to return the path. So if you go to example.com/posts, right? So post is what we want. So let's start with our tests. So we want to make sure that we're getting some subset of the URL. Before we do that, we're gonna have to keep, we're gonna have to keep adding these kind of dummy test values. So we could write that individually for every single item, or we can put them up here as class variables. So we'll talk more about that later, but for now we can do something like, let's do full URL equals, okay, slash posts. All right, so now I'm gonna use that here. So I do self, which refers to the instance here, and then full URL. So don't worry about this self stuff. We'll talk about that more later. So this should still work. Let's make sure. Okay, still works. So let's write our other test. So we want to make sure that this returns. Okay, so we got def, and we're going to do test because we need to make sure we prefix all of our tests with test underscore. So this is going to be tough to test exactly. So we have a couple different options, but I'm just going to go with something very generic just for the time being. We'll just see if it returns a string that's shorter than the original URL. So test router path shorter. So again, we could think of better names, but for now that'll be fine. And we can add a doc string. Test that the router parses the path from the URL, something like that. So it's not exactly testing that, but we'll pretend that that's at least a partial application. So we'll do self dot, and we can look at our list of assertions in the documentation. We can also look through here. So assert, you can feel free to refer to the documentation, but we're going to do something like less. We can do self.less, or sorry, assert less. So we'll go ahead and use that one. And we can see the signature here. So the function signature, so it can take, looks like a couple parameters and a message, which we're not going to worry about. Okay, so the first thing we'll give it is, so we want to check the length of this URL that we're going to give it and make sure that whatever we return is less than that. So we'll check that this URL is less than, again, we'll call our function webapp.url parser and self.full URL. So I got to add self here. Okay, let me expand this. Okay, so we write a test. We want to make sure that our function is chopping off the URL. It's pretty generic still. We'll take a look. Okay, cool. So I ran my test and it failed. So red, green refactor, we just have a requirement. We're implementing it. We're describing what we want using the test. And we run the test and it fails. So I get one passing test. My first test still passes, so that's good. The second test fails. So fail, test router, blah, blah, blah. So test that the router parses this is our doc string that we give. And it tells us that there's an assertion error and it describes what has happened. So example.com/post, not less than example.com/post. So no surprise there. So we can read the message that we get and know a little bit more about what's happening. So if we're doing red, green refactor, now we're at red, so let's make it green. So we need to write something that returns something that's shorter than the URL. So again, there's other intermediate steps we go under, but for the sake of time, let's say we'll return URL dot split and take the backslash, and then we'll do the first. So we'll take everything after the backslash there. So again, this is not robust, but this is fine for a model. So we take this. So now it should be shorter than that. So let's try running the test. It still fails. So I need to invert what I'm doing here. So I should have read the documentation more thoroughly. So I just need to reverse this. Okay, so that passed. Let me clear so we can see that. Okay, it passed. So now red, green, refactor, we wrote the test. Now we write the function and it passes. So good. Now we can start over again. So this is the process. I'm not going to keep going just for the sake of time, but this is the basic process that you use. So you're constantly writing tests, little chunks, and then you write code. It seems silly at first, especially in the beginning when you're testing, like if a function exists, because you can just write the function and see that it exists, but it's part of what it is. So yeah, let me take a look at my notes real quick. Okay, so I think that's all I wanted to cover for now. Unless there are no questions, we can take a very short break and we'll come back and talk about debugging and jest.